Hello, everyone. Welcome to our first speaker series session in 22. My name is Christoph Lüttke. I'm a professor of business ethics at the Technical University of Munich and the director of the Institute for Ethics in Artificial Intelligence. With our speaker series, the TUM Institute for Ethics in AI invites experts from all over the world to talk about ethics and governance of AI. These events serve as an important platform for sharing new research and exchanging knowledge. Since our launch in 2019, we were able to run 19 speaker series events. Because of these virtual events, in particular, we were able to reach an even broader audience from around the globe. So we are looking forward to hearing from you today during our discussion. Today, we are exceptionally delighted to have with us Christoph Bartneck and Dwain Allan from the University of Canterbury in New Zealand. They are here to talk about the perceived threat of robots. Let me say a few more words about our distinguished guest speakers. Christoph Bartneck is an associate professor at the University of Canterbury. He has a background in industrial design and human-computer interaction. More specifically, he focuses on the effect of anthropomorphism on human-robot interaction. And another research interest, he also works on bibliometric analysis, agent-based social simulations, and the critical review on scientific processes and policies, and if I remember correctly, also on Lego. And of course, we have been working together on this introduction to ethics in robotics and AI, which I have to say is turning out to be very successful. Dwain Allan is a doctoral researcher in the Human Interface Technology Lab, New Zealand, at the University of Canterbury. He has a background in design, marketing, innovation, and venture strategy with a special interest in technology-based entrepreneurship. His research interests are in the cross sections of social science, design, technology, and consumer behavior. And his current work in the field of social robotics examines the role of implicit self-theories in determining how individuals perceive, evaluate, and respond to social robots. Before we begin, I would like to ask you to turn off your microphone and camera during the session and submit your questions via chat or raise your hand. We will try to answer as many questions as possible. Also, please let us know in the chat if you are experiencing technical difficulties. So Christoph and Dwain, without further ado, the floor is yours.
Christoph, okay. So I'm going to be presenting a little bit about a paper that Christoph and I wrote. So I'll be talking to that. So I'll just share my screen now and hopefully this works. So this is our paper, Better Than Us, the role of implicit self-theories in determining perceived threat responses in HRI. This was conducted in collaboration with Andy von Asch and Christoph Bartneck. So first, I'm going to define perceived threat. Next, I'll discuss implicit self-theory. Finally, I'll put it all together and outline some of the results and contributions of an experiment we ran in order to assess the role of implicit self-theories in determining perceived threat responses. Before I do that, I'd like to invite you to read the paper. It includes far more detail than I could possibly cover in this short presentation. As well, it offers access to supplementary material and other bonus stuff that you may find, such as our data set and stimuli that you might find very useful. So what is perceived threat? Perceived threat, also known as threat perception, is a popular research theme in the field of HRI. The basic premise is as follows. Machines that are increasingly human-like and or highly capable simultaneously threaten human safety and resources, also known as realistic threat, as well as human uniqueness and identity, also known as identity threat. Several findings on the impact of perceived threat bear mention. First, robots perceived to outperform humans on a variety of physical and mental tasks increase feelings of threat. This is because humans view such robots as members of a highly competent outgroup and thus plausible competition for resources and jobs, as well as threats to human identity and distinctiveness. Second, autonomous robots, specifically robots capable of disregarding human commands, are considered to be particularly threatening. This is due in part to humans experiencing a sense of loss or control over robots. Third, and somewhat relatedly, researchers studying the Google DeepMind challenge, AlphaGo versus Lee Sedol, have reported that participants who viewed the challenge experienced not only threat to distinctiveness and resources, but increased feelings of helplessness. They also discovered that human intellectual comparisons with machine intelligence adversely affects people's motivation towards intellectual tasks. This interest in this topic brings up this question: what are the psychological determinants of threat perception? In our study, we propose that an individual's implicit self theory could be an important determinant of perceived threat. But what is implicit self theory? Implicit self theories, henceforth ISTs, also referred to as mindset and popularized by Carol Dweck's 2008 book Mindset, are underlying beliefs that people hold about the malleability or fixedness of self-attributes, for example, intelligence or personality. There are two kinds of ISTs, the incremental theory and the entity theory. Those who hold an incremental theorists, assume that self-attributes are mutable and amenable to change through self-development, effort, and education. Whereas those who hold the entity theorists, assume that self-attributes are largely fixed and unsusceptible to change. Obviously, an exhaustive review of this literature is not possible here. However, three characteristics warrant mention. First, people tend to endorse one IST more than the other, either incremental or entity, though the influence of such happens outside of awareness. Second, while considered to be reasonably stable and able to be measured as a trait variable, ISTs can be, and indeed frequently are, temporarily manipulated using scientific articles and other experimental stimuli. Third, and perhaps most relevant to our discussion, is that an individual's IST exerts a powerful influence on the traits attributes they make towards other people. For instance, entity theorists are prone to making stereotypical judgments about the traits of others and have been found to exert significant self-esteem as a result of being involved in stereotyping. Conversely, incremental theorists make fewer trait attributions and rather base their perceptions of others on situations and environmental factors. Of note is that stereotyping has long been identified as a key component in the formation of outgroup attributions. If you recall earlier, outgroup attributions have been linked to threat perception. Additionally, in our recent work, we have demonstrated that entity theorists, relative to incremental theorists, exhibit greater negative beliefs about robots. Importantly, negative beliefs about robots have been linked to realistic and identity threats. Drawing on this literature, we theorize that an incremental theory will decrease, whereas an entity theory will increase perceptions of threat. And we actually had 5 hypotheses, which I discussed at length in the paper, but due to space constraints here, I just want to focus on the 2 that directly relate to perceived threat. They are: 1, incremental versus entity theorists will rate robots in general as posing less versus more identity relevant threats. 2, entity versus incremental theorists will rate robots in general as posing more versus less realistic threats. The experiment used a 2 implicit self theory, entity versus incremental times 3, feedback, social comparison versus improvement oriented versus control between subjects factorial design. I won't go into too much detail about what the feedback types mean because they don't really relate to the hypotheses of interest today. Sorry. Other than to say that we were testing an unrelated hypotheses in which we predicted and found evidence of a matching effect between self-theory and feedback type. But you can learn all about that in the paper. Now, the experiment was performed in 4 parts. First, we experimentally primed participants' ISTs, turning some towards an incremental theory and others toward an entity theory. In the second part of the experiment, we expose participants to a video of human quiz players playing against and losing to an apparently autonomous intelligent robot. Here's what that looked like.
Meet Baxter. The Baxter is an intelligent industrial robot capable of answering questions posed in natural language. The robot is 6 foot 3 inches tall and weighs 306 pounds. Baxter has been shown to outperform humans on both physical tasks, such as weightlifting, and on mental tasks, such as chess and problem solving. What follows are highlights of an intelligence challenge that took place between the Baxter robot and players from a top university quiz team.
The original Doubting Thomas was a member of what group of people? Apostles. Correct. The motto on the flag of Brazil is in what language?
Portuguese.
Correct. How many points does the star on the Heineken logo have? 5. Correct. The Book of Secrets is the sequel to what Nicolas Cage film? Correct. What trimester begins with the 13th week of pregnancy? Second. Correct. The Paraha tribe comes from what South American rainforest? The Amazon. Correct. Abu Dhabi is the largest of what group of 7 states?
Baxter.
The United Arab Emirates. Correct.
So after that, in the third part, participants were presented with 3 kinds of feedback. And again, I'll encourage you to read the paper to learn what that's all about. At the end of the study, participants were then debriefed and compensated. So what were the results? As expected, incremental theorists perceive robots to be significantly less threatening to human identity and uniqueness. This result supports our identity threat hypotheses. With respect to realistic threat, as predicted, results revealed that entity theorists perceived robots to pose significantly more threat to employment and jobs. Why do these results matter? At a theoretical level, they expand the literature on perceived threat in HRI by showing that IST is an important variable underpinning perceived threat. As well, they extend our previous work on the influence of ISTs in HRI. On a practical level, these findings may hold value for HRI designers and marketers, not to mention open up some potentially important avenues for future work, all of which is outlined in the paper. To summarize, the findings of our study indicate that significant individual variability exists with respect to perceived threat. We show that some people, incremental theorists, are rather receptive to robots that can both physically and mentally outperform human beings. In contrast, others, entity theorists, view such robots as threatening. These findings support our previous work showing that ISTs serve as an important variable in determining how humans respond to robots. Okay, so I encourage you to get a copy of the paper. It covers our whole investigation, and you can access all of the bonus material with that as well. You can also reach out to me at the addresses on the screen. Thank you very much.
Thank you, Dwayne. It was wonderful. Amazing. How many slides were in your slide deck? Must be 100. Okay. Well, I don't have that many slides. Right, let's see if I can get my thing to work here. Share screen, keynote, share. All right, I hope you can all see the presentation now and hear me all right? Okay.
Yes.
Wonderful. So I'm also going to talk about threat, different kind of threat, and also different robot. Particularly, we were looking at the case of Boston Dynamics. And of course, you all will know Boston Dynamics from their famous robots. And here's a video that they recorded quite a number of years ago, and probably many of you will know this. This is the big dog robot, and they did a little test with the robot. So this was a test, and the idea was to showcase this robot's ability to balance. So if something surprising happens, well, you know, not necessarily a human kicking it, but something else, that it could balance itself very quickly. But this video became very famous for, you know, kicking a dog, you know, and that was perceived as, well, this is some form of abuse towards the dog. A lot of people got quite unhappy about this robot, or not the robot, but the human kicking the robot. That was perceived as inappropriate. But of course, they go further, and then they made the Atlas robot we have here on the right. And again, we had the experiment of pushing the robot and showcasing how it can rebalance itself. And also the demonstration was here tracking, so that the robot could track an object and notice that if it drops it, and can relocate it, find it, and go for it again. And it was a technical presentation of the capabilities of this robot. But many people thought that this is a form of teasing, really, where they do something to this robot which might be perceived as again, inappropriate. Now, of course, then we can go even further with this, right? So we cannot just tease him, but we can also do things like this. So this is a more robust form of, I guess, testing the abilities of the robot. And of course, why stop there? We can just go further. And this is another hardcore test of the Atlas robot, I suppose. And the interesting aspect here, of course, is that, oh yeah, sorry. The interesting aspect, of course, here is so far it was always the humans that would abuse the robot, right? But it doesn't have to be that way, right? So you can also, of course, do something else, namely that the robot would actually defend itself against this frequent abuse. And this is what we see over here. Now, a lot of people will, of course, know these videos and know that this was not real. This was actually computer graphics, and this was done by a company. And so this robot here is not actually a robot. This is a virtual model. But nevertheless, this is a very, very interesting video, and it really kind of went around the globe in a kind of a big media frenzy. And we got really curious about these videos, because whenever you want to investigate abuse towards robots, you have a problem, namely, well, how are you gonna present that? How are you gonna show that? How are you gonna make people experience this abuse? And in the past, we've done a couple of attempts at this. So for example, here is a very early study where we had a very small, very cheap robot, and we asked people to smash the robot with a hammer, which we can see here now. And that's all very nice and good, but it's very expensive if you want to have more advanced robots. And the next best thing, of course, then is that you can do video recordings. That's one way of doing it. Or you can also just let the robot roam around in the wild and just hope that by accident you occasionally observe abusive behavior just in the wild. But the problem there is it's not that frequent, and so you have to spend a lot of time recording before you actually get enough observations for the abuse. So a lot of people really did resort to present videos of abuse instead of giving people the actual experience of doing it themselves, or letting it happen in the wild. And this is just to, as a proxy, as really to make this possible. And for this purpose, these videos were really, really quite useful. Because what we have is that this company, what they did, they released later on a video in which they showcased how they did it. They did motion capturing. So they had a human actor which would act like, the victim here. And then they replaced that human with the robot, but they kept the movement of the human and mapped that onto the robot. And so we then approached them and asked them, hey, this is really great. Could you please give us your source material? Because this was for the first time we had a chance at seeing a video where we have identical videos. So once with a human, once with a robot, they did the exact same thing, that reacted in the exact same way, and it was a perfect comparison. So and also at a visual level that unless you really know what to look for, you would be very easily fooled to believe that this is an actual robot. So we used then this stimuli in our experiment. So you here see the mapping. So this is what they did. And again, if you know what to look for, you know that here at the robot down here, you see that the shadow around the legs, around the foot is not perfect. Once you know what to look for, you see it. But at the untrained eye and unexpecting eye, this looks very, very convincing. So our research question was then, and I'm actually only touching upon two here because the paper that we published on this is, of course, much more complicated and much longer. And one of the question is when the human gets abused or a robot gets abused, will that be perceived as morally differently? So would, for example, the abusing human be perceived as less morally acceptable than the robot? So we're looking at that. And the second thing we're looking at is when it comes to fighting back to a sort of a reactive aggression. So if you have the context of, well, you've been bullied now, several times, and then you decide to fight back, would that be more or less acceptable for a human or a robot? And we did an experiment which was a 2x2 with in-between experiment. It's slightly more complicated. There were some twists and turns around there, which, again, read the actual paper for the exact details, but essentially would have the agent being either or the robot or the human, and then the reactive aggression would also be either a human or a robot. And we had, unfortunately, a different number of videos because that was the only videos that were available. They only had actually 2 videos in which the robot would fight back or the human would fight back, and 14 episodes in which the human or the robot were victimized by bullying behavior. And also there were some other constraints, for example, that the bully was always a human, right? We didn't have access to a video where the bully would be always the robot. So there are some limitation and some constraints around, but nevertheless, for what it was. We then used some measurements for moral acceptability. We also asked about the intent to harm, whether what the bully did or the aggressor would do was it actually intended to harm the person. And we also asked about violence, so how violent was this action? And well, we had a video, and then after every video, people would have to rate this. And as a result, the moral acceptability of the abusive behavior was equivalent. So there was no significant difference between the robot being abused or the robot being abused. And that's very interesting because you could say like, look, a robot, doesn't feel pain and doesn't have any emotions. Why would it care if you kick it in the back? It doesn't care. It doesn't even care if it's switched on or off or if it's broken or not. It really doesn't care. So in that sense, if it doesn't matter for the robot, why would this even be a moral question at all? But I guess the focus here is more on the action of the human, that the human bully is doing something which is inappropriate. But then again, what is it really that the bully is doing here other than damaging some property, right? And that then goes into the question about representation. So is kicking a robot that has the shape and the appearance of a robot, what does this say or mean for the interaction? Because this is not just a random robot. This is a robot that represents a human, that looks like a human, that acts a bit like a human. Therefore, if you do something to the representation, it also is not the same as a pure object. So, I mean, we have it quite often when there's elections here. People go around with eddings and, make little drawings on top of the posters of the candidates. And again, you do something to the representation of this person and not just a nice drawing on a piece of paper. Now, but when it came to the response, so when either the robot or the human would fight back against the bullies, that changed. So here, the acceptability of this behavior was less for the robot. So while we do accept that bullying a robot or abusing a robot is just as bad as abusing a human, we still don't want them to fight back. So, and that comes back to the question of threat and perceived threat and dominance. So it seems that we're scared of this idea of losing control or really a robot fighting back. And that is, well, is it weird? Well, it is human nature, I suppose. But the real question is, if you have a robot, let's say that you deploy in a public space and this robot gets bullied, the question is, well, how do you respond to that? How do you program the robot to do something about when it gets bullied? And there are different type of strategies you can do. For example, the robot could just shut down and switch itself off and just become completely passive, and therefore maybe the excitement around this action becomes less, and therefore people just get bored and move on and do something else. Or you could run a strategy where you call for help. The robot could go around screaming, "Help, help, I'm being abused," or something like this. Or what you could also do is the robot could indeed show some form of aggression and saying, this is not okay for you to do that, right? And that could actually be potentially a successful strategy of evading abuse. But yeah, people are scared of that. And yeah, this is, of course, goes back to what Dwain already mentioned about mental and physical superiority of robots. That is something that scares us. Well, we're always afraid of the people who are stronger and smarter than us because we think that they will do something bad to us. So the idea that a strong and intelligent person or robot could be benevolent or could be good for us is something that we don't have a lot of trust in, I suppose. So these are actually already quite a lot of conclusions that I'm talking here about. We've done some other experiments on threat as well. And yeah, I guess with that, we could open the floor for questions.
Thank you both so much for this fascinating talk and all these fascinating examples. The next time I see something like this, I have to watch out for the shadow. So, okay, so we are opening the floor for questions. We have quite a large one. So the others, please help me if I overlook some raised hands. maybe I can ask one question to start with. I mean, certainly you have touched upon this in your talk, but why would you say are very human-like robots with high capabilities, especially threatening to humans or perceived as threatening to humans? Or are they? Maybe I'm wrong.
So the question is whether the level of anthropomorphism would
Yep.
influence whether people will be scared of it or not. Or so if you have, let's say, a very machine-like robot, but then it's just a machine, like a Boeing 747 is an extremely sophisticated machine, right? So very expensive, very intelligent, very strong, certainly stronger than I am. So you could be scared of this airplane. But I guess, well, we should by now be scared of Boeings. We just had the Netflix documentary about the failure of the 737 MAX. So where they put an autonomous system in, and that system didn't exactly collaborate with humans very well, or at least they didn't bother telling the people that it existed. So that is a real big problem. So yeah, I mean, when you have something like an airplane or a car that actually is in a position that it can physically kill you, we should be very concerned about it. Whereas a lot of the robots we currently buy for the home are pretty harmless because we can always just, unplug their battery, and that's pretty much it. So I guess, Dwain, following up on your idea about identity threat versus realistic threat. So I was right now talking about realistic threat, but I guess part of the question is probably stronger in the idea of identity threat. So Dwain, what are your ideas on that?
Well, Christoph, the original Christoph that asked the question, is the question something? Are you asking a question about the sort of the anthropomorphism of a robot? So, say if it looks more human-like, right, with hair and stuff, is that more threatening? Is that the question?
Yeah, I was also thinking of this, what is sometimes called the uncanny valley effect of bookkeeping.
I thought you were going there.
Yeah.
That's Christoph's favorite subject, actually, isn't it, Christoph? You can answer that one.
I do have a few more favorite topics to talk about, but let's not get into the uncanny valley. That will be a bloodbath. But again, the question about identity threat. So, would a robot that just looks more like a human, but not necessarily would be smarter or stronger than a human, be perceived as more of a threat than, let's say, a box that is incredibly smart? What do you think, Dwain?
Yeah, I would say that it would be more threatening based on the research that we have today. As if it's a box versus, say, like a Geminoid, as I would like to say, one of those robots that you've seen them before, perhaps. They look very, very realistic. They're made to look like a living human. Just in and of themselves, they can be very, very threatening. There's something about that. And whether or not you want to call it uncanny valley or there's other words for it, they bring up all sorts of things for us as humans. It could be something to do. There are some theories about it that it may be to do with the fact that they kind of look a bit dead.
Okay. So there's a question. Oh, sorry.
So Ishiguro, he used to give presentations, and during some of his presentations, he would just take a pen and poke it into the eye of the android. And again, what's the big deal? It's not like the robot would even notice that this would be going on. But a lot of people were like, oh my God, what's going on? What are you doing? And it's indeed you project so much humanness into them that this seems problematic or scary. But again, the question has always been, how long does this effect really last? Because if you get used to them and you notice that really, it's not that intelligent and it's really just a computer, this might disappear. But we didn't really have that many tests where we could have a robot like a Geminoid that would actually be able to present a physical superiority and a mental superiority in an actual scenario. I would never felt. Gemini can't even stand; it can't walk. It just sits down.
They're not that smart, no.
Yes, there was a related question. Would less human relatedness be better in some aspects?
Dwain, what do you think?
In some aspects, yes.
So it's a bit.
Yeah,
Well, which
absolutely.
ones?
Well,
Okay.
it depends on what you're going for. It really does. Like, it depends on what the use case is for the robot, where it's going to be used, what the community of use is, where it's going to be positioned, that sort of thing. That would make a big difference between what happens. But just what Christoph was saying before would be very interesting to get a Geminoid, because as he said, they're not intelligent robots. They're not smart robots. They're not even that strong, right? They're just kind of dummies. And so if you've got a Geminoid, it'd be really cool to do an experiment with a Geminoid and say a Baxter. Christoph, that could be a really
Baxter
interesting
would
experiment.
Baxter has manipulated and actually it can actually do something, whereas Geminoids are not designed to be functional. They're just, again, it's all about the representation. I mean, they after the Geminoids, he did the a new robot, which was the which one was it? It was a female robot, and it was not. And they really made a lot of effort into the intelligence, so they really put as much AI into it as they could, and they got pretty far with it in terms of what is currently possible. But of course, you can still not have a meaningful conversation with it over a longer period of time. It always breaks down at some point. So the mental superiority right now is limited to that what AI can and cannot do. So crunching numbers, yeah, sure, it can do that very well, but a lot of other things are not.
Okay. Here's another question regarding the reaction towards robot-human abuse. How about simple cognitive empathy? Because we know this behavior is unacceptable, whatever the context.
Yeah, is it? I mean, I don't know. Sometimes when I get angry, and I'm working in the garage on some stuff, I've smashed certain things, or and I just vented my emotions, and the cardboard box that got the beating didn't really care. So not necessarily. It really depends. Again, it's about the representation. This is something that, of course, Rob Sparrow brought up very much in a very dramatic paper, and he pushed it all the way up to rape scenarios. And the idea really is, is it acceptable? And his argument was no, it is not acceptable. Not because that thing is a thing, and you can do whatever to it what you want, but more really, and also not about consequentialism in terms of that, abusing a robot or something like this would lead you to become in general more aggressive or more abusive. That was also not the point. The point really is that what does it say about you and your relationship to other humans? What does it say about your relationship to women when you do these two representations of women? That was his main argument, as far as I understand it correctly.
And that would also tie into a conversation we had the other night around bringing social robots into the world. And what does that actually mean? Like, when we're starting to interact with these robots and say you start to build up a series of patterns of behavior of abusing robots in your home, what does that mean for you as a human? How does that develop your own views and ethics about what is right and what is wrong?
We were discussing it in the airport in Christchurch. They've got a couple of robots, and quite naturally, Dwain, you want to tell the story?
Oh, just about how they're chained up. Yeah, apparently. Yeah. Well, so they don't want the robots when they're not working, and they don't work a lot because I won't say what kind of robots they are, but they don't work a lot, right? So the airport have them chained up in an area so that people can't take them away and can't steal them. So that's my contribution, Christoph.
Well, again, it's a logical conclusion. I mean, it's possibly the right thing to do. Like, you don't want it to get stolen, so you put a lock on it, right? I mean, on a bicycle, you put a lock on it so not it gets stolen, right? So that's okay. But still, it feels wrong to chain up a human-styled robot. I mean, it just comes really close to some form of imagery of slavery, really. And yeah.
Okay, we have some more questions here. Do you think HRI can or even will shape human-human interaction at some point?
Yeah. I mean, it's an ongoing debate always. I mean, it's similar to the idea of computer games. Do computer games or violent computer games make us more violent? I mean, that's one of the standard questions. And so therefore, if you have some sort of behavior pattern with robots, would that also translate over to other things? And the answer is, well, it's complicated. But if we accept the premise that advertising works, then we will also have to accept the premise that these kind of interactions will have an impact. Or how do you see that, Dwain?
I would say it's most definitely a strong possibility that would happen, particularly if you were brought up with robots, right? So say you're a younger person and robots are around and we have them everywhere, and it's likely to be something that happens in the future to some extent, then why wouldn't it be the case that your model of interaction, if it's primarily with an other, like a robot, say, why wouldn't that have an effect on how you interact with other people?
I mean, yeah.
Okay.
At least to some extent, right? Like, I mean, I'm not sure it would explain all of your habits, but you would think it would have a strong effect.
Okay. We have more, considering the abilities a robot should have to protect itself. How about non-physical response, like an alarm or a reaction that does not hurt physically, like water spreading? Would that make a difference?
I tried this on cats with mixed results.
Okay.
Isn't there some interesting studies, Christoph? You probably know about them, where they've had like a dog squeal or something. They've taken a soundbite of a dog crying or something and superimpose it into a robot. Have you heard of this? I might be making this up, actually.
Well, there has been an old
I'm pretty sure there was something like that.
No, there's this old study where they confronted dogs, like biological dogs, with the Aibo dog. And when the Aibo dog was walking towards their food, they growled at it and eventually bit the robot because they thought it's food competition. They actually, and the anthropomorphism or the zoomorphism in this case actually really worked. Yeah, well, it's a fundamental question, which is, again, very, very difficult. How do you stop a bully? And if there was a simple answer for that, we would probably be much further around this in human-human interaction. And unfortunately, it is not an easy solution. So, of course, parents have this tendency to say, okay, if a bully hits you, you hit him back twice as hard, Doesn't always work that well. Or, if you say, look, just go away, or there's all kind of strategies that we try, and it's surprisingly complex. Supposedly, and I'm not an expert on bullying, but one of the more successful strategies is to call out for help and to call out for authority. So involve the bystanders essentially, and potentially adults to get them engaged, and therefore broaden up the audience, and therefore the bully would be pressured by the social presence of others not to behave like a bully. But again, could the robot do the same thing? Yeah, potentially, yes. But then again, we had so many some examples already where, like, some security robots, they just topple them over and push them into a pond or something like this. It's very easy to do that. It's not particularly hard.
Yeah. Maybe this is a related question. What about animals? If you compare animal abuse to robot abuse, how does it compare?
Yeah, there's this thing around people try to use animal legislation. So the idea is, like, animals are property, right? So you can do whatever you want with your animal. You can kill your dog if you want to, and that's perfectly legal. You can eat your dog if you want to. It's also perfectly legal. There's nothing wrong with it. So in that sense, it's property, and it has no legal stance at all. So a dog can't sue you, with the one exception that animal cruelty is not allowed. So you're not allowed to be cruel towards animals, and so you give them a little bit of a legal standing. And the idea brought forward was, well, could this be an example for human-robot interaction, in the sense that a robot, Sophia has got supposedly citizenship in Saudi Arabia, or UAE, one of those.
Yes, Saudi Arabia.
Yeah, but it's more of a gimmick than anything else, really, because it can't vote, it can't really do anything. But still, I mean, you could bring a law forward to say that cruelty against robot would also be unacceptable. Or what do you think,
So,
Dwain?
oh, no, I'll just add to I think something that's sort of inherent in that question is the sort of comparison between animals and robots. But something to remember about particularly humanoid robots that we're talking about here is that they don't behave the same as animals. Remember, they have these other social capabilities that we've designed into them. So they can talk, they can move around, and they can give feedback. So the comparisons between animals and robots have some limitations.
Well, so I mean, if you have a robot dog, I mean, the easiest thing, I mean, you probably put a speaker into it, right? And you can make it bark, of course. And it's the easiest thing to add a text-to-speech engine to it and let it talk, right? It's super easy to do. And as soon as you add speech to it, again, our patterns, I mean, the only other animal that we talk to are other humans. And then this kind of associations happen. But nevertheless, I mean, zoomorphic robots are probably still a good idea these days, simply because the AI that we have is probably at best at the level of a dog.
Here's another completely different question. How can you identify people's mind theory, incremental theory, and entity theory, and their occupation that matter on mind theory? Not sure I get that correct, but how you can identify this?
The standard way that they do that you identify people's implicit self theories or mindsets is using a measure. There's a measure where you can ask people a series of questions, and from that you can start to deduce what their mindsets are. But you can also tell, generally speaking, what people's mindsets are, because it has a lot to do with, for example, your ability to put yourself out there, right? An entity theory person, somebody who has an entity theory, is unlikely to do things where they're not already competent, right? They do not want to be seen as incompetent. So that's a very good model, a good way to sort of tell between the two, right? Whereas an incremental theorist, they have this mindset that is anything I do, I'm learning, I'm trying to get mastery, I'm trying to develop, I'm trying to grow. That's their kind of motivation, right? Whereas the entity theorist, the other one, they're more interested in maintaining their status, right? They don't really want to be seen to be incompetent. And what's interesting about that, I'll just say one thing about the implicit self theory, is that it has a lot of these crazy downstream effects that we're seeing, which is why it's interesting to the field of HRI, right? It's so if somebody has this, it's as we're finding now, an entity theory where they're very fixed in their ways, then when something new or is changeable, innovation comes up, they tend to be more resistant to that.
Here's a question.
As far as Dwain actually knows much more about this than I ever do. But I always got hard pressed about, so is there anything good about entity theorists? And it always seems like a negative, like they're not good. And Dwain educated me that particularly in the field of education, so when you have children, you always want to move them away from this entity theorists in terms of you can try, you should try, you should improve. A bad result doesn't mean you're stupid. It just means that you can learn more. We always try to push them in one direction. Or are there any really? Where is their advantage really?
Yeah, there was some research, and I think it was to do with relationships, where I think it was incremental theorists are likely to give people a lot of chances because they believe in growth, whereas an entity theorist will just be like, right, that's not good enough, right? So if we consider that for a second, you can start to see how maybe an incremental theorist could be taken advantage of over, say, an entity theorist. All right.
Okay.
Is that?
Here's a more global question, but related to the animal one. So Kant proposed that one can assess the value of a society by the way they treat their animals at a time when animals were considered tools. So what about how they treat their robots now? Any opinions regarding building robot rights, like societies build animal rights to protect themselves from unacceptable behaviors? This is a reference to Kate Darling. Okay.
You want to go first, Dwain?
I'm still thinking. I like the Kant
was
reference.
trying to
We actually have a
first.
robot. We've got a robot called Kant.
Yes, we do.
Oh,
Didn't
yes.
work so well.
Okay. Does it only stick in one place? Like
He's actually got a broken hand at the moment, doesn't he, Christoph? Has he still got a broken hand?
Oh, he's got something broken with him. We tried to name them all after either Greek or German philosophers, after the Monty Python sketch of soccer playing. Because I mean, now robots and soccer playing is just as good as them. And I didn't realize that Immanuel Kant can be very easily mispronounced in English. So that has been a bit of an issue for us. But coming back to the question about what does it say about our society? Well, again, what does it say about us individually as well? So, and again, it's not about abusing an object, because, well, we do that. I mean, I break stuff, and you know, okay, its property is not a good thing. You shouldn't break something. Yeah, wasteful. Yeah, okay. But that is nothing compared to the idea of literally. I mean, the example that you could bring forward, I could make a robotic copy of Christoph Lütke, and then I could take a baseball bat and smash the robot's head, right? I could do that. And I could program the robot to cheer and say, like, yeah, give it to me, I like that. I could do all of these things. It's possible. But what would that say about me? Other than that I like to break stuff, you know. So I think, yeah, indeed, it is really says something about our own moral values and our own virtues, really.
We have around 3, 4 questions remaining in the remaining minutes. So let's, if it's within human nature not to trust that strong robots are good for them, how can deployers mitigate the perceived threat and foster trust such that the robots can better serve their functionality? Any specific ideas?
Wow, I mean, so we can identify this as a problem, and I think it's probably deeply rooted in our human nature. Whenever a more superior civilization met a less superior or less developed society in the past, usually that didn't go down very well for the usually indigenous population. So we cannot be particularly proud of ourselves, and I'm not sure how much better we've become at that. It is really hard.
Is there one specific advice that you would give?
Well, I mean, at this point in time, really, we're so far away from this, right? I mean, we're really far away from this. I mean, the biggest threat right now would probably be more on the level of that we have some algorithms that can kind of influence us or influence our opinions or our political views, or that deny our loan applications. That is something where there's most influence right now of computer programs. But then again, you've got all this idea about, okay, but is it really the algorithms or is it the people who program the algorithms, right? And then you've got this kind of chain of responsibility here. And it only ever really gets interesting if there's a considerable amount of autonomy involved, because otherwise you'd always just point a finger back to the person who created it.
That's fine. I mean, if we come back to the question, though, the question was something about if machines are strong or robots are strong. It's not that they're strong. Like, that's okay. We're okay with strong robots. We've had industrial robots for decades. It's when they're strong and intelligent that becomes a problem, as Christoph's highlighting now. And so maybe it's possible that you reduce it's like anything, you turn the features off, right? You're bringing a robot into the workplace. This is, again, as Christoph said, it's hypothetical because we don't have a lot of these, intelligent and super strong robots in the workplace right at this point. But it is possible that you put a kitty lock on it. You just don't have those, well, you don't reveal those. I mean, part of our research around the entity and incremental theorists, we found that incremental theorists are very, very partial to the idea of having these intelligent robots. They like the idea of it. They can see themselves working with them. We've done experiments where we've had these robots marking them and running tests and things like that. But the entity theorists, of course, they don't like that. But it seems, though, that if we have the robots that are seen to be less threatening, maybe not as intelligent potentially, although they could be, they just aren't described like that. It's almost like a marketing question in some ways.
Well, I mean, one strategy said you could just play dumb, right? I mean, the point is, if you're very intelligent, don't be a smartass, right? I mean, you don't have to rub it into their face, right?
Yeah.
So in that sense, a benevolent,
that's it.
Strong, smart robot would not necessarily show that off.
No, we have three questions remaining, so maybe just one short answer if possible. One is, could it be that we perceive other human beings as trustworthy because we presume they also have the need for recognition, which gives them a vulnerability equal to our own, and this enables mutuality. So robots are in no need of affection, so the perfect sociopaths, which makes them scary. Is that a possibility?
Well, it also makes them perfectly predictable, right? I mean, if again, right now we have to very be careful not to mix fiction with science. So right now robots are really quite simple, and you kind of roughly know what's going on. And if your floor cleaning robot is able to reliably detect cat poo on the floor, we can already applaud. So this is the level of intelligence we're at right now. So yeah, I'm not so worried about that at this point in time, really, because it's just all fiction.
You could speak. Oh, sorry. You could speak to the fact that once again it's anthropomorphism, Christoph. Right? I mean, how many experiments have we run where people, they don't see the robots as sociopaths. They start to project themselves onto the robots and have all these relationships, and they're like, "Oh, you're so cute," and they start giving them personalities. And it's very, very strange for us as researchers, because most of the time we've programmed these robots to behave in a certain way, and we tell people, we say, "Look, we have programmed this robot; it is not intelligent," but they still go on and treat it as though it is. So again, it comes back down to Christoph's point about it's what's within us.
So if you look at the now, and if you just switch on the default live mode, where it just kind of randomly moves around, tries to find faces, it's just kind of very, very predictable number of behaviors. But people get fascinated by this already, and they project all this. Oh, now he's cute. Oh, he's looking at me. Oh, he's interested in me. Now he's interested in you. It's like they develop all kind of stories about what this thing is. But if you know what it really is, then you're much less fascinated by it. So I guess one way of dealing with it is just to educate people more about how robots work and what they do and what they can and cannot do. And that will, I think, remove a lot of this fascination.
So two last questions. One is currently already work being done to program a robot in a way that it can discriminate by itself a moral act from one that is not?
Oh, right. Yeah. So that's really, really, there's no quick answer for that. But trying to do it, ethics itself is complicated. We humans don't even really know what it is. So if we can just make the robot obey, let's say, or respect the law as we have it, then already a lot of things would be done. And solving ethical problems is similar to any kind of other problem. So solving a problem like, how do I bring a glass of beer over there is a problem. How do I achieve it? What do I have to do? And it is just planning and problem solving. Mm-hmm. And so ethics in a way is not that different from this kind of problem solving.
There is a whole field called roboethics, which runs the gauntlet on things like sex robots to military robots that kill us, all of that, autonomous vehicles. So again, I encourage people to check that out too.
Last question. EU is mentioning the need for human in the loop or human on the loop in their current proposition on the EU AI Act. Do you think ensuring the involvement of humans in the robots' decisions implementations could reduce the perceived threat and ease their wider introduction to society?
Not really, because look, there are certain, if you have an autonomous vehicle going around, you can't always ask the human what to do. I mean, it has to make decisions by itself, like red light, I have to act now. There's no point of involving a human really in that. And but again, it's a very big question about liability. That's where it really comes down to. And I just saw in the news today that in Germany now Tesla is becoming an insurance company and selling you car insurances. And the way you drive influences your premium. So, and again, keeping in mind that they now have cameras that point at you at all times. So it's getting very, very interesting, particularly because Tesla they've got their own witness. I mean, they've got their own surveillance going on, right? And I think mixing insurance with the guy who controls your car, I'm not sure if that's a good idea.
Yeah. So the other thing would be the idea of, as Christoph sort of alluded to earlier, is human in the loop starts to get a bit messy, right? Like, I mean, this is the problem we're having at the moment with data. It's and AI and algorithms and people thinking they're making decisions about them and stuff. Really, the problem really lies with the humans behind the AI. So we have to consider that too. So maybe it's possible that if you have too many humans in the loop, perhaps with these robots coming in, that the perceived threat could be heightened in other areas outside of what we've talked about.
And maybe we are out of time, but a very last question, because I like this question and I get this question a lot of the time. Where is Asimov and his 3 laws today in your picture? Is it still there?
We did a whole podcast episode on that one, actually, and we ripped it apart. So
I think we can refer to that.
Yeah, listen to that one. It's pretty good.
Good.
Well, the robo-ethics thing that I just talked about is actually based in part on, they started with Asimov's 3 laws, and that was their kind of guiding principles for the subfield. So it's still alive and well. People are still trying to make it work.
Yeah, but see, Asimov himself was a smart guy, and he knew himself that these laws are insufficient. And in his novels, he always plays this out, actually, and he demonstrates how these 3 laws are insufficient to solve all possible scenarios. So so we just, it's a very nice idea, but even Asimov knows that it's too simple.
Great, thank you very much. We are out of time, but I wanted to take a final moment to let you know about our next speaker series event with Thomas Hildebrand and Henrik Olsen on March 23rd, with Natsuka Tokumaro on April 7th and Manuel Herrans on May 12th. Last but not least, I want to remind you that the best way to stay up to date with our news and events is to visit our website, subscribe to our newsletter, or follow us on LinkedIn and Twitter. And of course, I would like to thank again once Christoph Bartneck and Dwain Allan for accepting our invitation, and all of you for joining us and contributing to the discussion with your questions, comments, and remarks. Thank you very much.
Thanks.
Thank you for having us.